A developer writes an application. Everything works perfectly. The code runs, the database connects, the API responds. Then they send it to another developer, and suddenly nothing works anymore. The app crashes, dependency explodes, versions conflict, someone whispers the ancient cursed phrase, "Well, it works on my machine." And somehow that sentence becomes one of the most expensive problems in software engineering. But then Docker showed up and basically said, what if we just shipped the entire environment too? And honestly, that changed everything. I'm Yukari Esther, and this is Neural Bloom, where we make complex technology actually understandable. So, if that sounds interesting to you, consider subscribing and leaving a like. It really helps the channel grow. And if you'd like to directly support future videos, you can also support me on Buy Me a Coffee. So, with that said, let's dive into it. Back in the old days, setting up a developer environment felt less like engineering and more like performing dark rituals. A project would come with a README file that looked something like this. Install Python 3.8, but not 3.9. Install Node.js version 14. Install PostgreSQL. Install Redis. Install these 47 packages. Configure environment variables. Sacrifice your weekend. And after all of that, there was still a decent chance the application wouldn't run. Because software doesn't just depend on code, it depends on libraries, operating systems, configurations, runtimes, database, and even tiny version differences. One computer might have Python 3.8, another Python 3.12, one machine Ubuntu Linux, another Windows, and suddenly the same application behaves completely different. It's like trying to bake a cake using a recipe, but every kitchen has different ovens, different ingredients, and somebody replaced the sugar with salt. Technically, you follow the same instructions. Emotionally, disaster. And companies suffered from this constantly. Developers wasted hours debugging problems that had absolutely nothing to do with the application itself. The real issue was the environment, not the code. The environment. Docker solved this problem using something called containers. And containers are honestly one of the coolest ideas in modern software engineering. Here's a simple explanation. A Docker container packages your application, your dependencies, your runtime, your libraries, and configurations into one isolated box. So instead of saying, hey, install all these things manually, you simply say, run this container. That's it. The application behaves the same way everywhere. Your laptop, your friend's computer, a cloud server, production, same environment, same dependencies, same behavior. It's basically software teleportation. Think of Docker containers like bento boxes. Every meal is separated its own little compartment. The rice doesn't invade the dessert. The sauce doesn't attack the vegetables. Everything stays isolated. Containers work similarly. Each application gets its own environment, its own dependencies, its own isolated space. Which means applications stop fighting each other because before containers, installing software on a machine sometimes felt like introducing two cats that immediately hate each other. One app needs Python 3.8, another requires Python 3.12. One uses an older library, another breaks if that library exists. Docker isolated everything so they peacefully coexist, which is honestly more than most group projects accomplish. Now, here's where things get really interesting. Before containers become popular, developers heavily used something called virtual machines or VMs. A virtual machine is basically an entire computer running inside another computer. And yes, that sounds absurd because it kind of is. A VM includes a full operation system, virtual hardware, memory allocation, storage, and the application itself, which makes VMs powerful, but also heavy. Containers are different. Instead of creating an entire fake computer, containers share the host operation system. That means they are lighter, faster, use less memory, and start almost instantly. It's the difference between renting an entire apartment versus simply reserving your own room in a shared building. Both give isolation, and one is dramatically more efficient. And this efficiency is a huge reason Docker exploded in popularity because companies suddenly realized they could run way more applications using way fewer resources, which translates to a sentence business absolutely adore. We can save money. Here's a practical example. Suppose you're building a web application. Normally, you need a backend server, a database, maybe Redis, maybe frontend, maybe machine learning service. Without Docker, setting all of that up manually becomes chaos very quickly. With Docker, each service runs in its own container. One container PostgreSQL, another your API, another frontend, another Redis, and they all communicate together like Lego pieces. This is why Docker becomes incredibly important for cloud computing, DevOps, microservice, machine learning, and scalable systems. Even huge companies rely heavily on containers because moving applications between environments becomes dramatically easier. Development, testing, production. Everything stays consistent, no surprises, and no mysterious dependency demons appearing at 2 a.m. usually. Here's something wild. Docker became so influential that it completely changed how modern infrastructure works. Technologies like Kubernetes, cloud-native systems, scalable microservices, CI/CD pipelines all have evolved around containers in a weird way. Docker didn't just create a tool, it helped reshape the structure of the modern internet itself. That tiny whale logo? Massive impact. At this heart, Docker is really about one thing: consistency. Software becomes predictable, and predictable systems are easier to build, deploy, scale, debugging, and maintain. Instead of developers saying, hopefully this works, Docker allows teams to say this environment is identical everywhere. And that confidence matters a lot in engineering because modern applications are already complicated enough. Nobody wants configuration chaos on top of that. So today we learned Docker solves the works on my machine problem. Containers package applications with everything they need. Containers are lighter and faster than virtual machines. Applications become portable and consistent, and Docker became one of the foundations of modern cloud infrastructure. And honestly, once you start using containers, it becomes very difficult to go back. Because after experiencing reliable environments, manual setup starts feeling like trying to assemble furniture without instructions. Possible? Maybe. Painful? Absolutely. If you enjoyed this video, consider subscribing, leaving a like, and turning on notifications so you don't miss future videos about software engineering, machine learning, and how modern technology actually works. And if you'd like to support the channel directly, you can support me on Buy Me a Coffee. Thanks for watching. See you in the next one. Bye!